Point.
You took this.
The last one.
I thought he's gonna fall over.
Okay.
Wow!
Look at the first question. Look at question 2. A circuit breaker. Okay, a circuit breaker. Read the question. Functions as a safety device to break the circuit when the exceedingly high current flows. So the current enters through T1 and then out through T2. So when you see a question like this, you might think it's very difficult. Look at the setup already. Scared. Some people will leave it blank, nothing to say. Some people will answer in a way which may not be correct. Okay, so you must know how a circuit breaker works. How does a circuit breaker works? Under normal situation, is there current flowing through a circuit breaker? Yes or no? Yes, right? So under normal situation, there's always current flowing through a circuit breaker. Then when does it break?
Too much power.
Too much current, right? Okay, so you see, this question, when you answer this question, some people answer actually quite well, no? But it sounds correct, but not correct. Okay? So how do they answer it? They say when current flows through when current flows through T1, goes through the solenoid, okay, then it magnetizes the core, attracting the soft ion amateur. Is that correct?
Yes.
Not correct.
Oh.
Under normal situation, there's always current flowing through the core. That means the core is very magnetized, but the core is not
Too weak.
too weak. Correct. So the important word you must think when you explain this question is different from the electric bell question. So how will you answer this, Elvis? When the current flows through, when what kind of current flows through the coil? Opposite of too weak is
Too strong.
too strong, right? When a strong enough current, okay, so keyword here will be strong enough. Strong enough current, set up a strong enough magnetic field. And then the magnetic field strong enough, able to attract the sub-ion armature and break the circuit. Okay, so how to answer? Okay, you can write it down this way. When a strong enough
No, underneath the control. Yeah, that's what you always do. Okay, fine. Okay, fine.
You know what the honest you do?
Okay, did it. Shall I go toilet? Good, right? Because touch you. Not touch you first. Yeah, that's what I mean. Have fun. Oh. Thank you.
Okay, so look at the question. Don't know whether you can phrase everything nicely. Okay, so I already say again. Answer questions to do electromagnetism this way. When a strong enough current, keyword strong enough, flows through the solenoid, it magnetizes the core to be something to attract the soft ion armature. Magnetizes the core to be what?
Magnetized.
It has to be what?
A magnet.
It's under normal situation already there is a magnetic field. But now
Strong.
it has to magnetize the core to be also strong enough. Okay, so just now Elvis was saying it's too weak. So when the current is large, okay, then it can be strong enough to magnetize the core to be strong enough to attract the soft ion armature and then break the circuit. So once the armature is attracted, the circuit is broken. Okay? So it's somewhat similar to like electric bell lah, but here yours is a circuit breaker. Okay, so it has to break at a large enough current. Okay. Okay, look at the second part. Explain how the circuit breaker functions if there is less coils. So less coils, what does it imply? Remember
less
this?
strong.
Huh?
Not as strong.
So how does the circuit breaker work now?
It will take longer to
Take longer?
take longer to magnetize.
Take longer to magnetize?
Need more current.
Need more current to magnetize, right? So again, so you may understand, but the phrase you should say is that it now will break at a higher current, right? Not need more time, but it needs a larger current. Okay, so it now needs a larger current in order, okay, for it to break. Okay, so this one. You will now need. Okay,
Yes.
that reminds me something.
Stand up. Get out.
What is it, me?
I don't know, he seemed like one like then after he gonna laugh, the cheek might laugh. He go,
You stop talking, Joshua.
oh, sorry.
Much higher.
A much higher current.
Sorry.
To attract the soft iron and choke.
Much higher current.
Why you take the use calculator?
Oh yeah, you. How do you find that out? How do you figure that out, bro? Because he just. To be strong enough.
You don't want to use.
Okay, so with less turns, less coils means your current must be much enough, higher, much higher than before to magnetize the core, to be strong enough to attract the armature and break the circuit. Okay, so modifications of questions like this. Can? Okay, so what's the situation over here? You look, again, is this electromagnetism?
Yes.
Still electromagnetism, right? You see got electricity, you got see two iron rods and a coil. Okay? And the coil, inside the coil there's there's a tube, okay? And then there are two iron rods here. So whenever this question comes out, this is actually a O-level question. Okay, and when I said it before, a lot of people get very confused with the role of the tube. Okay? They say things like this: when the switch is closed, current flows around in the tube. Okay? Or the tube become magnetized. Does the tube become magnetized?
Is it?
No. Okay, the tube is simply there to hold the wires so that the wires can go around it. Okay? So that's the role of the tube. Okay, nothing so the tube's role is not in a sense very important. It's just to hold the wires. Okay, so when your two rods are placed next to each other at the bottom of the tube, when the current is switched on, the two rods repel each other. Okay, so explain why. So those who have very answers, they simply say this, like poles repel. Right? You know like poles repel? Right? You learned before, right? The word said, right? So like poles repel. North and north pole repel, south and south pole repel. So they just say simply like poles repel. But how do you answer this? How do you answer this? Why is it that they repel? Why?
When they magnetize
Why? The ends, or you all tell me. Okay, you all use and tell me. You all apply. All of you should be able to know how to apply. Except her, okay, she first time come here, so she shouldn't know. Wouldn't know. Okay, so is this north or is this south? 50-50 chance of getting correct.
North.
I'm ready to take that
Do
back.
you even try?
South.
This two south, this one north.
This one west.
This two south, this one north.
North.
This is the straight A student. So which one?
Northeast.
Northwest.
Okay.
I say west.
What does Manhin say?
Both.
Okay, first step, you look at how the current flows. Current flows from positive to negative, so current flows this way, positive to negative like that, right? So over here, look at the way the current flows, it goes from the front to the back. So in order to find out the poles, you use the four fingers to follow the current. So the four fingers follow the current. So if this is the rod, the current goes from the front to the back. So wherever your thumb points, it is the what?
North.
North. Okay? So north. So if this is the north, the other rod, if this is a north, the other rod will also be a north. Right? Both will be a north-north. Then this both will be a south-south. Therefore they repel. Correct or not? Why are you confused?
The heading.
Current goes from the front to the
Back.
back. Front to back. Four fingers go from front to back. Where your thumb points is north, so this is north. Okay? So, how do you explain that in words? Okay, that is a challenge. How?
So is it say like the thing become magnetized?
So, as usual, how do we start off? When what?
When the circuit is closed.
When the circuit is closed, when the switch is closed and current flows through the solenoid.
Yes, sir.
I make sure they use more than 60
Joshua,
Yeah, okay. Everything agree.
okay, so let's review the answer again, right? So when the switch is closed, current flows through a solenoid magnetizing both iron rods, such that both ends facing each other have like poles. Okay? Since like poles repel, the two rods move away from each other. So that's how you phrase. Okay? Of course, there are other ways of phrasing it. Okay, you can of course say on the left side of the iron rod, both of them are north poles. And on the right side of the two iron rods, both of them are south poles. Therefore, they repel because like poles repel. Okay, so all about phrasing in this question. Okay, now look at this one. Okay, again the phrasing.
Oh, you just smack me. No. Good luck.
Wait, why you say it so casually? Oh, you just met me?
Joshua,
Oh yeah.
Elvis.
Scary.
Okay. So when the current flows through a solenoid, what to say next?
It will magnetize the iron rod.
The iron rod
Will be magnetized.
will be magnetized. Then,
While the copper rod will, as is
while the copper rod will not be, will not. Why? What's the reason? As copper is a non-magnetic. So again, you use the correct word. Non-magnetic is not the same as unmagnetized material. The copper rod will not, as it is a non-magnetic material. Okay. So very long answer and still not complete. Then what happens next?
Therefore,
Therefore what?
they will remain in their stationary position.
Okay, better than saying nothing happens, right? Hence,
other. Touching each other.
That's very annoying.
I helping you no more. Just making normal.
Okay, hence both rods remain in their position as no attraction takes place. They don't attract the rod. Okay.
Oh wait.
Okay, to help you answer the part C. Okay. So again, you start.
Good luck, that's it.
Walk more. You hit me, this I'll go here.
That's why it's studying water.
Alternating current.
I'm alternating current.
Press this sit down. I can't see. Oh,
No shit.
Press please stop touching people inappropriately.
Say it louder.
Say that already.
Outside, I think in here.
No thanks.
Like how you shout in the MRT.
Okay, guys.
Joshua is all.
Okay, so when alternating current flows through the solenoid, magnetizing both rods. So it's almost the same, except for a few words you're going to add in, such that both ends
What's this?
okay.
Both ends now facing each other.
We're continuously alternating poles or polarity. Okay, so that is the three words we add in. Right? So both are north-north, then after that both become south-south, then become north-north, then south-south, and so on and so on and so on. Okay? So when okay. So what is the result? As a result, what happens? As a result, both rods attract and repel. No, right?
Stay there, stay
Repel.
or stay repel.
Stay repel.
Oh, that's okay.
Both rods repel from each other. As like poles repel. Okay? So, again, so you see 3 times we keep on when we answer electromagnetic magnetism question, always start with what happens when the current flows. Okay? Magnetizes the core. Okay, and then what happens after that? Okay? So that's always the style we answer. Okay, so this question, O-level question ABC. Okay, so I add on one more part. Okay, don't know you got space to write or not. Okay, I will just shorten it. What happens when one rod is steel and the other rod is iron? What will happen?
Can you say when the circuit is closed?
Okay, when the switch is closed, right? Again, back to the same thing.
Flat.
Okay, when the switch is closed, both rods become magnetized. Okay, then after that, we skip to the end. And then after that, what happened?
The steel rod will still be magnetized.
You now have to say, okay, when the switch is closed, both rods become magnetized, but when But when the switch is open, weapons, Yongxiang weapons, the steel rod, what's the word to use? Don't say steel attract, retains its while iron loses its magnetism. Okay. Because like Wan Yin said, steel is a hard magnetic material, whereas iron is a soft magnetic material. Okay. So then as a result, Elvis, what happens? The end result, what do you see happen?
The steel attracting the iron rod.
Okay, as a result,
What? Let me give him a chance.
the steel rod attracts the iron rod. Okay.